And thank you very much to the organizers that you have invited me and that you give me the opportunity to share the information on our activities with you. HPM for EU is a very big initiative which we run jointly in Europe. And in Europe, we have a good reason to take care of chemicals because we have currently more than 155 million chemicals being registered in the CAS registry. We have a 50% increase in production over the last 20 years, as indicated by our Chemical Industry Association in Europe. In many countries of Europe, chemical industry is one of the largest manufacturing industries. We have about 34 million tons of carcinogenic, mutagenic, and reproductive toxic chemicals on the market in Europe. Well, and from our calculations, we expect the chemical production to increase much steeper than the development of the population, and we expect a doubling in a time frame of 24 years for the chemical production, and that means that also the benefits from knowing better which chemicals impact health and the environment will grow increasingly. So HPM for EU. Who are we? We are a joint program of 30 countries in Europe plus Israel. The last two who joined in were Estonia and North Macedonia. Both are very interesting because they suffered from Russian pollution conditions until the end of the Cold War. And so these countries represent a specific type of exposure. We are a 5-year program currently with a budget of 74 million euro. We are financed or co-financed by the European Commission, and we have 117 partner organizations with 450 people working in HPM for EU currently. The whole initiative is coordinated by the German environment agencies for which I work. And the next project is already under preparation because the Council of the Environmental Ministers in Europe have decided that this work needs to be continued. So we're a project at the interface of science and policy, and our major goals are to answer open policy relevant questions as defined by the EU services and by the partner countries. We have a very special structure. The partner countries are always or have to be represented by those ministries and national programs which generate exposure data and or run the research programs. And so the EU services, this means the general directorates, which are some kind of EU ministries, plus the EU agencies in charge of chemical policy and chemical management. Then our second overarching goal is to give policy makers a fast and easy access to results and data, because in the past several programs or numerous projects and programs were run in Europe, but the data were just kept more or less secret or only being published to some extent in peer-reviewed journals years after they were produced. And for policy making and protecting humans and the environment, we need access to these data much easier and earlier. And of course, as a third overarching goal, we want to bridge the gap between science and policy by building up a network which is capable to really bridge this gap. So we have a general procedure to translate results into policy. And one very important aspect is the prioritization of chemicals. As I just said, we have 155 million chemicals in the CAS registry. And when we want to start improving our chemical policy and regulatory measures, we need to focus on some examples of the highest concern. And so we started to map the needs of policymakers from the partner countries and the EU bodies, as I said. We had a number of criteria which candidate chemicals had to fulfill. Of course, the hazardous properties, regulatory status, exposure characteristic, public concern were some of them. Then we scored the chemicals based on these criteria, consulted afterwards the EU Policy Board and the national hubs and stakeholders. National hubs are those coordinating units in the HPM for EU partner countries. So we covered all people involved and interested in either human biomonitoring or effects research, and the respective ministries financing these national programs, and consulted them on the priorities we had identified. Well, and when we came to a conclusion, we developed scoping documents for the prioritized chemicals or chemical groups, and have then developed the research plan. So in the first round, which we did before we started our program, so to say in the proposal development phase, we have identified 9 substances and substance groups, which are shown here. Inter alia, phthalates and substitutes, because the focus on phthalates, I mean, nearly every biomonitoring program today contains phthalates, but unfortunately they do not reflect the shift in the market. And what we clearly see is, especially from the German programs, that the substitutes are gaining more and more importance. So we put the phthalates plus the substitutes on the priority list, bisphenols, perfuranate compounds, and also the others are known to most of you, I guess, and the 2 overarching issues of chemical mixtures and emerging substances or chemicals of emerging concern. In the second prioritization round, we have then identified additional chemicals like acrylamide, aprotic solvents, deisocyanates, mycotoxins, or UV filters. And a third prioritization round will take place in preparation of the subsequent project next year. So around these chemicals, we have then designed a demanding work program to determine the body burden by human biomonitoring, to study effects, and also to further develop the risk assessment schemes. And risk assessment schemes are, for those who are not so familiar with regulatory processes, so to say, a combination of science and conventions. So, and these conventions work well, but they do not necessarily lead to the best protection of human health and the environment, which we have to safeguard for our populations. What we are doing, as I said, we have a number of studies ahead in Europe, but we did never know if data were comparable. And that was due to a number of technical implications, as, for example, study protocols, SOPs, guidelines, and questionnaires, which were of very different quality and made it difficult to compare data and also to interpret data. And that was why we started setting up a whole bunch of questionnaires for the priority substances for different age groups, where we have basic questionnaires, satisfaction questionnaires, and so on, so that all studies now being conducted in Europe can be conducted according to the same technical prerequisites. Then we have developed standard operating procedures, which were built upon the existing knowledge in Europe, of course, because we have some very long-standing programs in Europe. For example, in Germany, the German Environmental Survey, or the FLACE cohort in Belgium, or also studies in Czech Republic. And we learned from these experiences to build up the new stuff for additional new studies and also for use in the HPM for EU program. And of course, we have developed materials for the communication with study participants, which have to fulfill, of course, some technical requirements, but also ethical requirements. To produce biomonitoring data which are representative for Europe is not an easy task. In Germany, we have a randomly chosen sample which represents the people living in Germany, But this is not feasible for the whole of Europe, at least not in the first step. And that was why we developed an ambitious scheme to investigate exposure of children, teens, and adults, always with a focus on susceptible groups. And we followed the concept of North, East, South, and West Europe, and we decided to include in every partial study representatives of North, South, and East and West, at least 3 from each of the 4 regions. We decided not to investigate all chemicals in all age groups, so that was just a limitation because of the costs and, well, the feasibility, because we are currently in a stage of preparation of a permanent European human biomonitoring program, but it's not the final stage which we have reached. Then we have had to develop, of course, the protocols, as I said, started the field work and the chemical analysis, and that is a stage where we are currently. And of course, for the interpretation of the data, we would also like to get additional information on our study participants on income, sex and gender related questions, and housing conditions, for example, because human biomonitoring is, of course, the method of choice to investigate the whole aggregate exposure taken up by all pathways and coming from all sources. So it gives the best view on a realistic, real exposure of a population. But we also want to know where these exposures come from. And finally, we want to identify measures how we can reduce the exposures and protect people from impact of chemicals. And that was why we need additional information. So we do not solely work on the general population. We also have targeted studies in the occupational field. Human biomonitoring was first established decades ago in the occupational field in Germany, for example. So it's a standard measure to control workers' working conditions and if they comply to the protection requirements. Well, and now in our study, we decided to focus on some cases, and one was chromium-6 is a carcinogenic chemical substance, and the study is conducted or has been conducted in 8 of our partner countries. We have analyzed chromium and also perfluorinated compounds, nickel and mangan, in welding companies. Where relevant, we have investigated these chemicals in 4 different matrices, and we are currently in the phase where the sampling and analysis has been finalized, and we are waiting for first results. That was a success story because access to occupational exposure data is very difficult. Companies don't like to share them. On the other hand, scientists or regulatory scientists like us have difficulties to access the company's stuff. So we got it organized, and this success led us to the conclusion that we have to continue with 2 additional other occupational studies, one on the isocyanates and the second on waste workers, where we want to investigate the levels of plasticizers and some heavy metals. The quality assurance is much more important than one would expect. It sounds a bit boring, but that was one of the main obstacles in the past, that you could never be sure that people measure the same and if the measurement is correct. And that was why we have introduced a very ambitious ICI-EQUA scheme in EUPM for EU. We have investigated 9 groups of chemicals, 73 biomarkers in 4 different biological matrices in 25 countries. We've conducted 4 rounds of this ICI-EQUA scheme, and we have involved 7 labs EU-wide in the organization of these quality assurance activities. What we learned is there are many volunteers, but that does not necessarily mean that they measure what is really in the samples. And now we have identified in this activity, which took us about 2.5 years, a number of chemicals, a number of labs which are able to measure at a very high quality standards the purity chemicals in question. And the program has been a full success because we have now distinguished between high quality labs and those who have still to develop. We have developed capacities in Europe. Some recommended to go approach that one chemical is just measured in 1 or 2 labs, but that was not supported by the partner countries because most want to build up own capacities and also to get checked the qualities of their existing laboratories. And of course, we could identify in this project the needs for further development, the needs for training, and also we could introduce several improvements. So currently the analytical phase is ongoing. We have a number of partners involved in every activities, and as you can easily see, we've made a big progress, and now in the aligned studies, which bring together newly conducted studies plus existing data from established studies with a recheck on the analytical quality of the data. We are now on a good way to assess the data in the next year. And for the second list of purity substances, the ICI-EQUAS scheme has been a bit modified because we need to speed up, and we will conduct quality assurance for pesticides, arsenic compounds, mycotoxins, and acrylamide, and hope to finish the quality assurance activity as well as the data generation next year. So the network which we have built up now for Europe covers the whole of Europe. We have thus the opportunity for a knowledge exchange, for enhanced collaboration, and also for improving our European capacities. Of course, we have cooperated in this field also with, for example, CDC and ENHANCE. Antonia Calafat always supports us, and we have some international partners who are in a close exchange with our work. But I think this information might also be interesting for you because some of you might have human biomonitoring questions which are difficult to solve with the capacities you have available. Or if you are seeking for an exchange on a technical level, you can see that in all these countries you can find partners. And when you go to our HPM for EU website, you will find the addresses. And so for some of the chemicals, we have many laboratories in many countries, like for the bisphenols, 25 laboratories in 16 European countries. And for some, like the organophosphorus flame retardants, there are just few labs in one country, but contact us when you're interested, then we can supply you with contact details. So the data management, we've now passed the analytical phase, and the data management is of course also a challenge. And we learned a lot about this because we are aware of the need to increasingly and fastly share data and cooperate and investigate research issues with data sets brought together from different areas. What we had to take care about was the prior consent of the data owners. A data owner is, for example, our Ministry for the Environment, which owns the data of the German Environment Survey and the data from the German Environmental Specimen Bank. Then we had to integrate human biomonitoring data in HPM because data are brought together from different sources from all the partner countries. And then we had to grant access to data to work packages for their respective tasks, because when we have German data, for example, which will be analyzed in the Netherlands, they need to get a direct access data on an ethical and data protection appropriate way. And this is a field where we have now developed a lot of experience. And of course, we had to find a way to make the data available. It was planned to make them available via the platform EUPM, which is run by the European Commission. But unfortunately, there were some issues still not solved, so that we had to introduce our own repository. And the IPChem are now the metadata and some aggregated data, but not to the extent necessary to do real data analysis. We hope that in the near future, IPChem can deliver what we've expected IPChem to deliver, and that is full data sets. If you visit IPChem, you can find there already numerous data sets from Europe with the aggregated data, and it's freely accessible. When you know the contact details of the study owners, then you might also get in contact when you seek further cooperations or when you're interested, for example, in data exchanges, because all the templates and procedures we have developed include also options and ways how we can share data sets also with individual data with other research groups. And our ambition is, of course, to enhance this in Europe, but we are also looking for international cooperations. So we got a new EU data protection regulation 2 years ago, which raised a lot of troubles and challenges. We are currently, the good news is, with this big initiative, we are on a good way to go through all the legal interpretations and set standards on how to deal with that, because individual data, and we are talking in some cases about data sets of 2,000 pieces of information per participant, have to be strictly protected against misuse. On the other hand, we need this complex data set to understand how exposure occurs and also how exposure might impact health and well-being. The interpretation of the data is a key task of HPM for EU. We have identified the policy needs and the science gaps. Then this way I just talked about the study design, fieldwork, identification and quality assurance of exposure markers, data storage and data analysis are very important steps. But additionally, we need to learn more about exposure pathways, the substance of emerging concern. We need to find out at a very early stage if a chemical has a health impact, and of course the mixture effects are of a high concern, because human biomonitoring is also the best method to give information on the real exposure situation. And in Germany, from our last German environmental survey, we know that there's not a single person who's not exposed to more than 50% of the chemicals we studied in our JERIS-5. Well, and if we have this complex information, we can go for support of policy, and also we can identify additional research needs. We have combined health and human biomonitoring studies. There are some countries which have already experience in this field, like France, Germany, or Israel. And we have developed, we have first done an analysis of difficulties and benefits of such a combination, then have developed a strategy and are now developing such approaches further, because many countries have a health surveillance system, but not with a biomonitoring module. The proposals we've developed are now tested in some additional studies in Europe. Similar, we have included birth cohorts in our investigations, where we also are enriching birth cohort studies by human biomonitoring investigations to make better use. And there are many advantages, especially from a practical and financial perspective, when you combine them at one time and then have a full data set. We have also used for the interpretation, well, let's say established regulatory toxicology. We have developed a human biomonitoring guidance values, similar to the BEs developed by Toxicology Summit, or by the HPM values developed by the German Human Biomonitoring Commission. They are based either on toxicological or epidemiological data, and include the interpretation of the levels we find for the specific and sensitive markers we've investigated, and we have already approved biomonitoring guidance values for DEHP and for the substitute DINCH. These values are developed for the general population, for different age groups, and also for workers. And currently a number of additional guidance values are under development or in the process of reaching agreement, because interpretation of such values has always a political implication, and that's why we decided to give them proposals for a commenting round to all the national hubs, so that all partner countries can include all the specialists they deem helpful in the interpretation and critical review of the proposed value derivation. And finally, we then consent on a value which has, of course, a high acceptance because of this broad contribution opportunity to contribute. Well, the mixtures in human biomonitoring, we would understand a mixture as the combination of those chemicals or their metabolites which are at a certain point of time present in a sample. And we have developed a method, or we are developing methodology to better understand and interpret these exposures. The methodology has been prepared and the start was made with using the data from the Belgium study, which is a smaller study, and then in a next step compared with the German data. The German environmental survey, which I mentioned earlier, is a population representative study which is representative for age, community size, former East and West Germany, where we still see differences even 30 years after German reunification. And in JERIS, we have investigated a large data set, comparatively large data set of about 100 substances. Additionally, we do ambient monitoring in indoor air, dust, and drinking water. So we have a very big data set. And for the HPM for EU activities, at this stage, just 14 out of the 100 markers were included. And the investigation goes towards analyzing correlations in a time trend perspective or for different age groups. And this here is first results about correlation patterns in JERIS 5. Of course, there are big similarities when you look at younger children, 3 to 5, or the 6 to 11, or the young adolescents, 12 to 17 years old. But this is an under-complex estimation up to now, because, of course, it would be very interesting to see what it means if we intercorrelate all 100 chemicals investigated in JERIS. And we are aware that these chemicals just represent those which we have chosen in a targeted approach, and that they clearly underrepresent whole chemicals present in German children, adolescents living in Germany. So in HPM for EU, we have additional, a more political approach, together with 4 other EU-funded projects on mixtures, Euromix, Eurotox Risk Solutions, and EDC Mix Risk. We have developed a position paper on research needs and actions from our perspective to be taken at the science political level, at EU level. And we have then sent this position paper to the General Directorates for Research, Health and Environment at the European Commission. And later, a number of researchers co-signed this position paper. And we have also developed a current state of mixtures activities in the EU and worldwide, and published this paper. So the EU is currently defining priorities and research budgets, of course, for the years from 2021 on. And that was why it was so important for us to give this science political statement on what kind of research is needed, what kind of capacities are needed, and where are the research and regulatory gaps from the perspective of all these people from Europe which join forces and knowledge to derive the recommendations. In HPM for EU, we are additionally doing a study called Specimen in 5 countries, which are here indicated in blue, covering also north, west, and east. South is not so well represented here. And when we identified, or when we thought which chemicals we should identify, we became aware that crops are often sprayed 20, 40, 50 times in one season, and there's not a regime which chemicals or which pesticides are used, and it's completely intransparent which farmer uses which combination of pesticides at which time. That was why we came to the conclusion that the interpretation of these studies should be done by a suspect screening for pesticides, and only in some selected cases by a targeted approach. In this study, we want to compare how close the study participants live to the spraying areas. We want to investigate the influence on different age groups, study populations and countries, compare spraying and non-spraying season, and also work on identifying typical combinations of pesticides being used. It's very ambitious, and I'm really looking forward to the results. We have just started with this study most recently, but until the end of next year, our partners promise to deliver the results in all terms of chemical analytics and interpretation. So they have a very tough job ahead, but it's fortunately led by our partners from Netherlands, which are very skillful and ambitious, as we know. So additionally, we work on 5 case studies on mixtures and health outcomes, for example, on entry-androgenic chemicals and male reproductive health, which is important because it covers also the issue of additivity. We know from the phthalates and some other entry-androgenic pesticides that they have additive effects. And we are here analyzing available literature and developing advanced scheme for a proposal for an improved risk assessment, because we know already from the data and their analysis that the current approach to regulate single substances clearly underestimates the risks of these chemicals. Modeling, Dennis Zarianis was already mentioned earlier. Dennis Zarianis is the work package leader for the modelings. We use biomonitoring data to cross-check and improve models which are used normally in the exposure assessment, but we also want to identify the pathways by use of models. We have included effect biomarkers and AOPs in the studies. First, we have identified novel, traditional but less used biomarkers, and also some innovative biomarkers to cover the process from molecular events to health outcomes for the priority substances. And we have also identified a number of chemicals, of biomarkers of effect, which will now be integrated in some of our studies being conducted in HPM for EU. We have harmonized and synchronized a system for suspect and non-targeted screening. The regular human biomonitoring, the established human biomonitoring, is always a targeted measurement, but we have the unknown unknowns, which we will catch by suspect screening, and the unknown unknowns for which we need to go for a non-targeted screening. For the suspect screening, we have, in a cooperation of all these partners from Europe, developed now a harmonized system so they can measure now more or less the same, and we have developed a standardized procedure. For project at the Science Policy Interface, communication is key. Here on our website, www.hpm4eu.eu, you can find everything we have produced, all deliverables, as soon as they're accepted by my team and the European Commissions. They will go to this website. Before they are published, the results, also data will be found there. You find there the scoping documents for the priority substances, which include policy questions, information background on effects on exposure available up to now, and you find also all these standardized study materials, which might be interesting also for you. Then we have a flyer for the general population, just a very brief one. We have newsletters twice a year. We have an online library where you can easily find information on biomarkers and all the technical stuff. We have fact sheets on the chemicals, the scoping documents. We have materials for stakeholders. Here are the deliverables. Then we have some policy briefs for the policymakers and also for the population, where they can see what a chemical can do to them and what they can do to prevent exposure. We have introductory videos, and last but not least, we have many partners here. You can see the management board. Those are the 13 people who took over a major part of the responsibility, inter alia Robert Barucchi, who was mentioned earlier, Geert Schüttes and Agelia Castaño, who lead 3 different pillars, and well, on the others are the work package leaders. Work package 15 is led by Miriam Newton and Eric Lebret from our IVM. Well, and of course, thank you very much for your attention, and please visit our website and contact us if you have any questions or if you seek cooperation where we could help potentially.